the first one, it said that 60 cm cube of hydrogen diffuse through a porous spot in 10 seconds. How long will it take 30 cm cube of oxygen to diffuse through the same ports? Now, there's something I want to give you. I want to give you some background information on this, on how to solve it. And by the time we finish this, I want to encourage you to stay with us. By the time we finish, I will be able to know some of the basic ways of handling problems like this and why it will not be. And you know how you're going to handle it so that it will not be an issue even in exam hall. So here, remember that Graham's law says that the rate of diffusion of gases is that inversely proportional to the square root of their vapor density or molar mass. That is, rate is inversely proportional to square root of the relative molecular mass, or what? Square root inversely proportional to vapor density. Let me use VD to represent vapor density. So that is what it states. So, and we know that rate is inversely proportional to time. If rate is inversely proportional to time and we are asked to find time here, it means that if we are to use this, if you are to fix it in this place, it means that time is what? Directly proportional to what? Relative molecular mass, or also what? Vapor density. These are the two key things you should note here. So, but then let's look at the question we had. The question said, as the question have already stated, we are finding the time to take the oxygen 60 cm cube or 30 cm cube of oxygen to diffuse. Now, what are we going to do here? We are comparing the two gases. If you have to compare the two gases, the rate of that timing we have to be, okay, yes, and then we have square root of the molar mass. That's what we're going to go with. Now we know that for hydrogen, the molar mass of hydrogen is what? Hydrogen is what? 2. That of oxygen is what? Is 32. That is 16 times 2, 32, because it's diatomic. Hydrogen is also diatomic, so we have this. So comparing both of them, we can use this formula to get it done. So the first thing we do here now, we need to know the volume of, we need to know what you do. Take 30 cm cube of hydrogen to diffuse. That's the first thing you're going to do here to get this question done. So we know that 60 cm cube of hydrogen takes what? 10 seconds. Then 30 cm cube of hydrogen will then be 10 over 60 times 30 over 1. When we cancel off this, we have this will give us 5. That is 5 seconds. It will take 5 seconds for this to happen. So now we have what it will take 30 cm cube of hydrogen to diffuse. So now we can now compare them. Since they are in the same volume, we can now compare them. If we are to compare them, it means that for hydrogen 5 seconds. Then oxygen, we don't know. Now this one is for oxygen. Then the relative molecular mass of hydrogen is 2. That of oxygen is what? 32. That is what we have. So to get this thing done, open the bracket. To open the square root, to square both sides. If we square here, if we square this place and square here, we will have 25 over d squared. And then here will be 2 over 32. So this kind of thing, this can cancel. We have 1. This here we have that will be 16. Then what do we have to do next? This crossing over, we have t squared equal to 25 times 16, which will be something like this, 400. So to get the timing now, since we have 400, the square root, to get the square root, it will be equal to square root of 400 That will give us 20 seconds. That is what it will take us to get this thing done. This question said, if 20 cm cube of oxygen diffuses through a porous spot in 3 seconds, how long will it take 40 cm cube of chlorine to diffuse through the same ports if the vapor density of oxygen and chlorine are 16 and 36 respectively? So now we're using the vapor density just like what we have done before. And the major thing here now is that the difference is that we're using vapor density this time instead of relative molecular mass. Now, what do we do here? With the same formula we have, we can say T2 equal to now Vd on the 1 all over Vd of O on the 2. So for this calculation we are going to be doing now. So now we have 20 cm cube of oxygen, but here we have 40 cm cube of chlorine. So we're going to do the same thing again. So what do we do here? If 20 cm cube of oxygen, let's say oxygen, yes, takes what, 3 seconds, then 40 cm cube of oxygen will then be 3 over 20 times 40 over 1. This will go, this will go, this, that. We have to 2 times 3 will give us 6 seconds. That's 6 seconds. So if you have any question, you can leave your question in the comment section. We'll always attend to you. And now let's go down. We have what it takes 40 cm cube of oxygen to diffuse. It's 3 seconds. Now we can substitute. We can use this. The first one will be our time for oxygen. This is 6 seconds all over that of chlorine that we don't know. So the next one we have the vapor density of oxygen is what? 16 squared. Then the vapor density of chlorine is what? 36. So it seems that this one has a square root. So this will also equal to this one. Square root of 16 will be 4. Square root of 36 should be 6. So what we do here is 6 t squared. I believe you're following, over 4 and 6. This can also cancel. We have a 2. This cancel here. We have a 3. So when we cross multiply this, 6 multiply 3, we have, and 2 multiply T2. 2 times T2 is equal to 3 times 6 times 3. Then what next? T2 will then be 6 times 3 all over 2. Sorry, 2. 2 here we have 1, 2 here we have 3. Then 3 times 3 we have 9. That means 9 seconds for this to happen. Alright, thank you so much for being part of the class. And if you have any question, leave it in the comment section so that we can always attend to you. If you're joining us for the first time, we want to encourage you to subscribe to our channel. Please don't forget to share.